Hello, this is William from Visual Components, and this is part 3 of the Basics of Working with Robots video series. In this video, you'll learn about Robot World Frame, Robot Base Frames, Tool Center Points or Tool Frames, and Robot Configurations. Let's go and get started with Robot World Frame. To access a robot's world frame in the 3D world, go ahead and go to the Teach tab, select the robot program, and now you can right-click anywhere in the 3D world to translate the world frame or rotate the world frame. You also get an indication of where the world frame is in the component. Certain components have the world frame at the bottom of the component. Other components put it in the belly of the robot, depending on the axis the robot has. So for example, this robot here has it in the belly. If I select this robot over here, the robot world frame is at the bottom of the robot. And for this robot, it's also at the bottom. Alright, so now I'm going to talk about robot base frames. To work with the base frame, go to the Teach tab and select the base from the drop-down list. If you also want to see the available base frames in the robot, click the pop-up menu here, then Edit. This displays a base frame dialog that shows all the available bases the robot has. You can also create a new base and delete bases. Each base frame has its own set of property values, so any adjustments you make to a base will be updated in this dialog. When creating a robot position, select the base you want to use from the drop-down list. For example, I'll use Translate tool now, and create either a point-to-point or linear motion statement. So when you create the motion statement, it's now referencing base 1's location for its XYZ rotational values. So for example, if I was to translate base 1, the robot position that's referencing that location also moves as well. Now a base can also be selected directly in the 3D world. For example, if I use the base filter, I can then select the base and I can modify it with the function toolbar. Now if I want to change the base for a robot position, I can select a position in the 3D world. I can use the drop-down list here for bases, and then use the touch-up command. So now when I translate base 2, I'm also moving that robot position that's referencing its location. Now bases are primarily at the robot world frame, so if I want to set a base frame to a different component's node, I can use set node. Notice the robot world frame here. I can now use the drop-down list to select a component and its node, or I actually can select a component in the 3D world, or actually you're selecting the component's node, like so. I actually go set back base 2 back to the robot world frame. And since the robot world frame is the parent for base 2, I'll use translate, change it to the parent coordinate system, and reset it back to that 0 value. I'm now going to give you an example of how you can work with bases and change a base location during a simulation to pick products. So to the left of the robot, I have a component creator. So when I run the simulation, hey, I get those beautiful orange blocks. So I'm going to go ahead and use base 1. And since the component creator is a static component, I'll go ahead and use it as my base 1 node. So this will be the parent node for base 1. If this was an arriving or departing palette, then I recommend you use the world frame. So I'll go and translate base 1 now to be at the corner point of the product here. So I'll do snap positions and snap on that point there. Alright, let's go and create some robot positions. So I'll use translate tool and I'll go and snap positions. It should be the face center of the block, but I also want to use snap on orientation, like so. I'll create a pick position, so I'll go and grasp then. I'll retract up or pick up, linear motion. This will be my approach point as well, so create a point-to-point motion. So the robot will go to position 3, go down to pick up, grasp, and then pick up. So I reset. Alright, the robot picks up. Aha! So it's headbanging. I actually have the robot's program's executor on looping mode, so I'll select the robot, go to the param tab, and I'll turn that off. Alright. So now, what if I actually want to translate base 1 to this location here to pick up another product? I'll go to the Teach tab, and I'll create a change base location statement. I select which base I want to change, And now this is important to remember. I could enter the exact XYZ rotational values for base 1's new position, or I could change the base relative to its current location using this property checkbox here. Notice that the base 1 location is changed relative to its node, or the robot world frame. So I'll go ahead and close this out, and now I'm going to go ahead and take a measurement. So I'll go Tools, Measure. I'm going to use Snap-on Coordinate System to select base 1, like so. I'll then use Snap-on Point to select this point here. So I want to move base 1 to this point here, so I need to change it 150 along the y-axis. So I'll go ahead and exit out of my measurement, go back to my change base location statement, and I'm not going to change the x-axis. I'll clear the position y field, and now I'll right-click to use that y distance I just took from the measurement of 150. Zero out z. Alright, so now I click Close, I reset the simulation, and I change base 1, and notice the positions change as well, so I don't have to recreate all those positions again. So now if I was to loop the program, the robot picks, and it picks. Alright, and it keeps on going like so. Alright, so that's an example of how you can work with bases and change a base location during a simulation. I'm now going to talk about tool center points, or robot tool frames. To access a tool frame, go to the Teach tab and select it from the tool drop-down list here. You can also see all the available tool frames in the robot program. If you wanted, you could click the pop-up menu, select Edit, and a dialog displays all the available tool frames and their properties. You can also create new tool frames and delete them. One difference between base frames and tool frames is that a tool center point is usually in a robot's node, such as its mount plate. Now when you select a tool frame in the Teach tab, the orientation of the tool frame is indicated here by the origin indicator in the 3D world, as well as the tool frame itself. When you create a robot position, such as a linear motion statement, that motion statement will reference the tool frame. Now notice when you translate a tool frame, like so, and you run the simulation, notice that the effect is on the robot itself, its joint configuration, and the tool frame still has to go to that target position. I'm now going to give you an example of how you can work with a tool component. So here in the 3D world I have a weld torch that has its own tool frame. Now these type of components usually export tool frame, base frames, and joint values to a robot to work with. So I'll go ahead and use PNP and connect the tool component to the robot. When I connect the robot to the tool component, I now have access to the tool component's tool frames, such as the weld tip. And I can use it to create robot positions, like so. Now, when I modify a tool component's frame in the Teach tab, look what happens. So I have weld tip now, and I'll translate it. Notice that the robot creates a copy of that weld tip frame and modifies it. However, in the tool component, the original position of the weld tip frame is still shown. So I'm only modifying a copy of the tool frame, because if I was to select a tool component and disconnect it from the robot, notice the changes no longer apply, and I can no longer use that tool center point in the robot. So now if I was to reconnect this tool in a different robot, I still have the original weld tip frame good to go. Alright? So when working with a tool component, understand that the tool frames that are exported to the robot to use are only temporary. I'm now going to show you how you can mount and dismount a tool during a simulation. Sometimes when you're mounting and dismounting tools, you do need to modify the robot's action script behavior, and I will show you how to do that in this video. Right now the tool component is connected to the robot. I'll use PNP and disconnect the tool component. I'll now select Translate Tool, and I'll snap the robot to the tool component's node origin, like so. That'll be my mount position. I'm now going to use a set binary output statement, and if you remember in previous videos you used signals 33 through 48 to mount and dismount tools. So I'll use signal 33, and value of true means it will mount the tool. If I create another robot position over here to move the tool, and I run the simulation, alright, so nothing happened. That means I need to go ahead and modify the interface of the tool component with the robot in the action script. So I'll select the robot, go to the Param tab, Signal Actions, and click Configure. In the action configuration map, I'll go down to signal 33, and I'll change the interface from PnP flange to be tool for both mount and dismount or unmount. Now detection volume size I will talk about later. Basically I'm using tool frame 1 and it has to detect an interface within the XYZ values here. I go back to the Teach tab now. I reset my simulation. The tool mounts. Yes! So now if I want to unmount the tool, I'll create a set binary output statement. Signal 33, and it has to be false to unmount. And I'll create another robot position over here. Reset, run the simulation, mount the tool, dismount the tool. Alright, now let's talk about detection volume size. So for this mount and dismount I'm using tool frame 1. If I was to select tool frame 1 and translate it, for example along the x-axis, and now I run the simulation again, the robot cannot detect that interface because of the detection volume size for tool frame 1's current position. So if I want, I can use a change tool location for tool frame 1. And let's see, let's go ahead and change it relative to its current position. So I'll go ahead and make it minus to move it back up. Close. Move it to the front of my robot program, or sequence, sorry. So now when I run the simulation, tool 1 goes back, it mounts the tool, unmounts, like so. I can actually slow that down for you. Oop. So tool 1's there, and now I change the tool location temporarily. It can detect the interface, so it mounts the tool and unmounts. Finally, I'm going to talk about a robot's configuration for a robot position. So when I create a robot position, I'll use translate tool, create a linear motion statement. Notice in a linear motion statement, I cannot change a robot's configuration. However, if I change this to a point-to-point motion statement, I can now have access to change the position's configuration from this menu here. I can also use the Teach tab in this drop-down list here to change the robot's configuration for that position. If I want to make this the robot's configuration for the position, I can select it here in the drop-down list, and I can use the touch-up command here. So when I reset, the robot goes to that configuration, its joint configuration for that robot position, like so. If you have any further questions, please feel free to visit our community at community.visualcomponents.net, and please look forward to a final video of the Basics of Working with Robots video series. Have a nice day.